In this video, we'll be going over sort lists. So given the head of a linked list, return the list after sorting it in ascending order. So in our example, we're given this list, and then we want to sort it into, we have 4, 2, 1, 3, and we want to sort it in ascending order, so 1, 2, 3, 4. So we will be implementing a merge sort for this problem. Now, how can we implement merge sort? If we are given a list X, we will first want to break it apart or break it in half. Then we can sort the lower half and sort the upper half before merging them into a sorted list. Now, how can we find the head of the upper half? Because we want to sort the lower half, and we already have access to the head of the lower half. Now we just want to have access to the head of the upper half. Now how can we find the head of the upper half? We can implement a two-pointer approach. So one pointer, slow, will move one step at a time. And then one pointer, fast, will move 2 steps at a time. When the fast pointer reaches the end of the list, the slow pointer will reach the center of the list. We should also make sure to disconnect the upper half from the lower half. This can be done by keeping track of the previous node of slow, which is the node right before slow. So we can set that node .next to null to disconnect the list. Now, how can we merge two sorted lists? We can also implement a two-pointer approach. So one pointer will be in one list, and then one pointer will be in the other list. Then in each of the iteration, we will append, or we will add the node with the smaller value to our resulting list. Now let's go over the pseudocode. So we're going to implement the recursive merge sort. And now what parameters do we need? We first need head. So the head of the lower half. Now what's the base case? If head is equal to null, or head.next is equal to null, this means the list is already sorted. Because if its head is equal to null, we do not need to sort it. And then if head.next is equal to null, this means we only have one node. We do not need to sort one node, so we just return head. Then each of the recursive call, we'll first find the head, or head 2 of the upper half. Let's create a method for this. So we're going to create a method to find the head of the upper half. We're going to, then what parameters do we need? We need the head of the lower half. Then in the method, we're going to create the following variables. We're going to have a slow, the slow pointer moves one step at a time. And then we'll have a fast, the fast pointer moves 2 steps at a time. Then we have the previous node of slow, which is the node right before slow. This is used to disconnect the list, disconnect the lower half from the upper half. Now, while fast or fast.next or and fast.next is not equal to null, we want to set previous to slow, Then I want to set slow to next, to slow.next. And then I want to move fast 2 steps. So fast.next.next. Now we want to disconnect the lower half from the upper half. So I want to set pref.next to no. Then slow. Then we can return slow, which is the head of the upper half. Now we have the head of the upper half. We're going to recursively sort the lower half. So head stays the same. And then we're going to recursively sort the upper half. This list is different now because we have disconnected the lower half from the upper half. So head, turn to head 2. Then now I want to merge the 2 sorted lists. Now we can create a method for this, for the merging too. So we're going to create a method for the merge. So what parameters do we need? We need the left, the head of the lower half, and then right, the head of the upper half. Then in the method, we're going to create the following variables. We're going to have the sentinel head, so the sentinel head of the sorted list. And then we're going to have sentinel tail, so the sentinel tail of the sorted list. Initially sentinel head. Now while left and right or right is not equal to null, we want to append the node with a smaller value to our sorted list. So if right is null or left is not null and left.val is less than or equal to right.val, so we can put parentheses here. This means we can append the left node to our resulting list or the sorted list. So set sentinel tail.next to left. Then we're going to set sentinel tail to left. Else, and then we can set left to left.next. Move it to the next node. Else, we want to append the right node to our sorted list. Then we can return sentinel head.next, which is the head of the sorted list. Now let's go over the time and space complexity. For the time complexity, we get O of n log n, where n is the number of nodes. Now let's go over y. For the log n, we get log n because we break the list in half each time. Then we have n because we merge the 2 sorted lists. Now let's go over the space complexity. The space complexity is O of log n, where n is the number of nodes. This is our recursive call stack memory. Now let's go over the code. So we'll first go over our base case. So if head is equal to null, or head.next is equal to null, this means we do not need to sort it. We can just return head. Now we want to find the head of the upper half. So get head of upper half. So we're going to create the following variables: the slow pointer, the fast pointer, and also the previous node. So while fast is not equal to null and fast.next is not equal to null, we want to save the previous node first. So set pref to slow and then move slow 1 step. and then move fast 2 steps. Then we want to disconnect the lower half from the upper half. Then we can return the head of the upper half. Now I want to return a merge of sort list of the lower half and also sort list of the upper half. Now let's perform the merge. Left, list node, right, lower half and upper half. And then we're going to create the variables, the sentinel head, and sentinel tail. And then while left or is not equal to null, or right is not equal to null, we want to append the smaller node to our sorted list. So if right is equal to null, or left is not equal to null, and left.val is less than or equal to right.val, we want to append the left node to our sorted list. So sentinel tail.next is equal to left, and the sentinel tail is equal to left. Then we want to move left forward. Else we want to append the right node to our list, the sorted list. Then we can return the sentinel head.next, which is the head of the sorted list. Let me know if any questions in the comment section below.